Now we are entering section B. This is section B, pure mathematics. Find the derivative of 4s minus 7 over s squared with respect to s from first principle. Okay, this is quite a long one. We're going to handle it now. We are talking about first principle. Thank God you have idea in function. Every function, every f of s equals to y. Every f of s is y. So be careful with what you are going to see here now. Okay. This question 9. From first principle, recall that f of x, y equals f of x, and y plus changing y equals f bracket s plus changing x. Okay? Now, question was given to us 4s minus 7 all over s squared. Recall that y equals f of s and y plus changing y equals f of s plus changing s. So we are given 4x minus 7 all over s squared. This thing is the sentence as what? F of s. Is the sentence as who? Y. Good. But if you want to make this thing easier for you, decide to solve them separately. That is, solving for 4s using first principle. I am seeing this one now as my y, which is this y. Look at it, y. I will write 4x plus the y equals to 4 into, which is the function 4f, okay? X plus changing x. I will expand here now. This is 4x plus 4 changing s. So that 4x plus changing y equals this, okay? So 4x, that's changing y, delta y equals 4s plus 4 changing s minus 4s. This will take care of this. It will now remain changing y equals to 4 changing s. Dividing through by the s. dy ds equals 4. If you want to know if what you are doing is in order, there is a general formula, n s n minus 1. Your n represents the power. What is power of x is 1. So this is a represents 4, n is 1, s is s, 1 minus 1, 4 times s raised to the power 0, 4 times 1 equals 4. So you can see that one, it has been taken care of. Now the next one under the first principle is what? 7 all over s squared. Forget about the minus. When we are done, this solution minus this solution, okay? So this guy equals this, that is y. I will now say 7 all over s squared plus changing y equals to 7 all over x plus changing s all squared. That is the meaning. So now, I will have 7 all over s squared plus changing x, changing y equals 7 all over s plus changing s into s plus changing s. 7 all over s squared plus changing y equals 7 all over s squared plus 2s changing x plus changing s all squared. This is what we have now. This thing is going to be that change in y equals 7 all over s squared plus 7 all over 2s changing s plus 7 all over changing s all squared minus 7 all over s squared. So that this will take care of this. Now what is remaining? The y equals 7 all over 2s changing s plus 7 all over changing s all squared. Now dividing through by the s as the s, okay, dividing through by the s, you know, a fraction, changing s, you only do it at the denominator. Okay, this into this s squared plus this is changing this. Okay. Okay, to be on the safe side, this means minus 2, that's minus 14s minus 3 is what you expected to get as the solution, or minus 14 all over s cube, all over s cube. S squared minus 1, that's minus 14 into this, okay? Minus 14 all over s cube. If we divide through by this, you can even interpret this as this is a constant 1 times one multiplied by 1 over s squared times 7, okay? Now looking out for our expansion here. This is this, okay? Okay, let's say from here, s squared plus change to change in s, okay, plus change in s all squared, change in s all squared. Let's expand this. This s squared plus s changing s, okay, that's 2x changing s, okay, 2s changing s, s changing s, where is then? Okay, the expansion is in order. changing y to s changing s plus changing s all squared minus 7 over s squared. Now our LCM, good. This is changing y now equals, this is 7 all over s squared plus 2s changing s plus changing s all squared minus 7 all over s squared. Our LCM now is these two things, that is s squared into s squared plus 2s changing s plus changing s all squared. This, the y equals this. So if the whole of this go, it will remain 7s squared minus, this guy goes 7 into the whole of, that's s squared plus 2s changing s plus changing s all squared. Good. Now, dividing through by dy ds, that is, okay, let me come over this side. Recall, we'll have the first solution as 4. Let's keep it somewhere. 4, first solution. So now, dy all over ds. The rule for fraction of first principle, denominators are not being divided by changing s. No. So this will give us, dividing through by our numerator, we'll have, before we do that, this 7s squared minus 7s squared minus 14s cubed changing s minus 7 changing s all squared. Okay, so this guy can take care of this guy. So we now divide changing s all over the denominator s squared into s squared plus 2s changing s plus changing s all squared. So dy ds now equals, if I divide this, it will give me minus 14s cubed, then minus 7 changing s, okay, divided by s squared into s squared plus 2s changing s plus changing s all squared. As ds approaches 0, we now say that dy ds is going to be dy ds equals minus 14s cubed minus 7 times 0. Recall, as this approaches 0, all over s squared into s squared plus 2s into 0 plus 0 square. So this will give us minus 14s cubed minus 0 all over s squared into s squared, because everything here is 0. This will give us minus 14s cubed all over s4. So now, if we divide here by this, seven times this, okay, 7s squared 14x 14x, it's not cube, 14s, okay, this is 14x. So this implies minus 14 all over s cubed. Recall, from general formula, we got minus 14 over s cubed. And from first principle, we also have minus 14 over s cubed. So to finalize our solution, the question is what? 4s minus 7 over s squared. First solution was who? 4. Second solution, the operator is minus. While the second solution had minus 14 all over s cubed. Therefore, dy ds equals to 4 plus 14 all over s cubed. Or you can say dy ds equals to 4s cubed plus 14 all over s cubed. This is the differentiation of the first principle. So we are done with it. That is the differentiation from first principle. 4s minus 7 over s squared equals to what? 4s cubed plus 14 all over s cubed, or 4 plus 14 over s cubed. That is the solution. It's quite a long one, but don't bother so much. Just try to understand how to solve it, because you cannot avoid further maths by being long. The B part of this said, given that tan P equals 3 over s minus 1 and tan Q equals 2 over s plus 1. Okay, tan P equals 3 all over x minus 1, while tan Q equals 2 over x plus 1. Find tan P minus Q. Tan P minus Q, if you can recall, that tan A minus B equals tan A minus tan B all over 1 plus tan A tan B. Do you remember? Good. Now we have this. We're going to say that tan P is what? 3 over s minus 1, then minus tan Q, 2 all over s plus 1, divided by who? 1 plus 3 all over s minus 1 into 2 all over s plus 1. Tan P minus Q equals this, okay? This will give us LCM is s minus 1 into s plus 1. This coming here, this is 3 into s plus 1 minus 2 into x minus 1 divided by 1 plus 6 all over s minus 1 into s plus 1. Okay? So we're going to have that this equals, this is 3s plus 3 minus 2s plus 2, okay? All over s minus 1 into s plus 1 divided by 1 over 1, meaning 1 into s minus 1, s plus 1, plus 6, all over x minus 1, s plus 1, okay? Then, we're going to have, this will be equal to 3s minus 2s is s plus 5, okay? Divided by s minus 1 into s plus 1, all over, let's expand here. This is s squared plus, that's minus 1 plus 6 all over s minus 1 into s plus 1. This implies s plus 5 over s minus 1 into s plus 1 times, this is 1 multiplied by this times this. Okay. To this is this minus s minus 1 plus this. Okay. Times s minus 1 s plus 1 all over s squared plus 5. So this will take care of this, this will take care of this. This is going to give us s plus 5 all over s squared minus 5. So that is the solution for P minus Q. P minus Q, s plus 5 all over s squared minus 5. Okay, that's what we have. This is question number 10 now. Okay, question number 10 is about 10i, a quadratic polynomial has this g of s as 2s plus 1 as a factor, and if g of x is divided by x minus 1 and s minus 2, the remainder are what? Minus 6 and minus 5. Respectively, find g of x. Okay, meaning they are interested in the equation. General equation for quadratic polynomial is as squared plus bs plus c equals 0. Okay, the first one, according to remainder theorem, 2x plus 1 should be equal to 0, so that 2x equals 0 minus 1. That is subtracting 2 from left-hand side and right-hand side. So 2x equals minus 1, x equals minus 1 over 2. So we have to substitute this into this equation, meaning a into minus half, all squared plus b into minus half, plus c equals 0. So that's a all over 4 minus b over 2 plus c equals 0. If you look at this, the LCM should be 4. A minus 2b plus 4c equals 0. A minus 2b plus 4c equals 0 multiplied by 4. A minus 2b plus 4c equals 0. So here, a minus 2b plus 4c equals 0, equation 1. The other one is s minus 1. According to remainder theory, is also equal to 2. S here is 1. Substituting this value here, we have a into 1 all squared plus b 1 plus c equals minus 6. So a plus b plus c equals minus 6, equation 2. The other one is s minus 2. Being equal to 0, s here equals 2. So to substitute a into 2 square plus b into 2 plus c equals minus 5. 4a plus 2b plus c equals minus 5. equation 3. Okay, look at our equations. Equation 1, equation 2, equation 3. If we use this to form a matrix, recall that the matrix AX equals B, where A is the coefficient of all these equations. Here, equation 1, coefficient of A is 1, 1, 4, minus 2, 1, 2, 4, 1, 1, into A, B, C equals B. What is our B? 0, minus 6, minus 5. Now let's get determinant of this matrix. Determinant delta A, let's say the matrix is A, will give us 1, 1, 4, minus 2, 1, 2, 4, 1, 1, plus, minus, plus. Determinant is plus 1 into 1, 2, 1, 1, plus 2 into 1, 4, 1, 1, plus 4 into 1, 4, 1, 2. So our determinant here now, 1 into 1 minus 2, plus 2 into 1 minus 4, plus 4 into 2 minus 4, to give us minus 1, minus 6, minus 8 equals minus 15. So our determinant is minus 15. Okay, coming back to this side, we're going to have to get the value of A equals change in A all over determinant. Likewise, B, change in B all over determinant. C, change in C all over determinant. Using determinant method of matrix, to get A, we have to replace the whole of this place with B. Meaning that for A implies here 0, minus 6, minus 5. So minus 2, 1, 2, 4, 1, 1. The determinant of this will imply plus, minus, plus. This is 0, of course. It has nothing to produce, cannot produce anything. So we are forging ahead to this. This into minus 6, minus 5, 1, 1, plus 4 into minus 6, minus 5, 1, 2. To give us 2 into minus 6 plus 5, plus 4 into minus 12 plus 5. This will give us 2 into minus 1 plus 4 into minus 7. This is minus 2 minus 28 to give us minus 30. So A now equals change in A all over determinant. This implies minus 30 all over minus 15. A here equals 2. So the value of A now is 2. The next, you solve for B. Solving for B, replace here. When you replace, let's replace it. To solve for B, we have to replace. This is 1, 1, 4, 0 minus 6 minus 5, 4, 1, 1. For B, plus, minus, plus. This implies, of course, plus 1 into minus 6 minus 5, 1, 1, I'm jumping this because 0 will not produce anything. So this 1, 4 minus 6 minus 5. So we'll have 1 into minus 6 plus 5 plus 4 into minus 5 plus 24. This is minus 1 to 4. So this is 19 to give us minus 1 plus 76. This is 75. Therefore, B equals change in B all over determinant. This equals 75 all over minus 15. B now equals minus 5. Okay, now we have A, we have B. To solve for C is not a problem. Solving for C, any of the equation can serve you. Let's say A minus 2B plus 4C equals 0. You know A is 2, B is minus 5, plus 4C equals 0. 2 plus 10 plus 4C equals 0. So that 12 plus 4C equals 0. 4C now equals minus 12. C equals minus 3. Now we have A, B, C. The question is find G of X. Therefore, G of X equals A. What is A? 2. S squared. B minus 5S. C minus 3 equals what? 0. Therefore, G of X equals what? 2 squared minus 5S minus 3 equals 0. You have absolutely provided solutions for G of X. Therefore, the next question, find the zeros of G of X. You have nothing to fear about the zeros of G of X. Rather, all you got to do is to factorize. That's just what they want from you. So, coming this direction here, we're going to factorize 2s squared minus 5s minus 3 equals 0. Linking method. Here will give us minus 6s squared. What are the two numbers when I add? If I multiply, it will produce this for me. I may suggest 2 and 3. Minus 2 minus 3 is minus 5, but minus 2 times minus 3 is plus 6. But here we have minus, so it's not going to work. So the best thing here, I think, minus 6 plus 1. Minus 6 plus 1 is minus 5. Minus 6 times plus 1 is minus 6. So perfect. The two numbers are what? Minus 6s and s. So 2s squared minus 6s plus s minus 3 equals 0, okay? So that if I factor out 2s, it will remain s minus 3 plus 1 into s minus 3, all equals 0. So 2x plus 1 and s minus 3 equals 0. So zeros of G of X implies what? S equals minus 1 over 2 or 3. Final solution for that question. So the next question goes this way. Find the third term when this is expanded in descending power. Okay, let's expand that to get the third term. Okay, this is x over 2 minus 1 raised to the power 8. This is x over 2 up power 8 minus, okay, plus 8 combination 1 s over 2 power 7 to minus 1 or 1 plus 8 combination 2 s over 2 6 minus 1 2 plus 8 combination 3 s over 2 power 5 into minus 1 3 plus 8 combination 4 s over 2 4 into minus 1 4 plus 8 combination 5 s over 2 3 minus 1 5 plus 8 combination 6 into s over 2 power 2 minus 1 6 8 combination 7 s over 2 power 1 minus 1 raised to power 7 plus 8 combination 8 s over 2 power 0 minus 1 power 8. Okay. Actually, they are interested in third term. So expanding this will be a wasting of time, but I expanded it so you can see how you expand anything that has something to do with fraction. You counting from here, this 1, 2, 3. So the choice may be from here, choosing here 8 combination 2, s over 2, 6 into 1. But that's a perfect square. So let me press 8 combination 2. 8 shift 2. Nice. 8 combination 2 is 28. Then multiply by x power 6 all over 64 times 1. Our solution here now is what? 28s power 6 all over 64. If you want to break it down, fine. This is 14s power 6 all over 32. This is what? 7s power 6 all over 16. So the third term here is what? 7x power 6 all over 16. This is solution for question number 10. 10b. And that is the solution for question number 10. Question number 11. Expand 8s squared plus 8s plus 9 all over x minus 1 into 2x plus 3 raised to power 2 in partial fraction. Okay. So this implies a over x minus 1 plus b all over 2s plus 3 plus c all over 2s plus 3 all squared. So 8s squared plus 8s plus 9 equals a into 2x plus 3 all squared plus b into x minus 1 into 2s plus 3 plus c into x minus 1. So 8s squared plus 8s plus 9 equals a into, we use cover up rule as s minus 1, okay? using cover-up rule, s minus 1 equals 0. Therefore, s is 1. So 8s squared, that is 8 into 1 square plus 8 into 1 plus 9 equals a into 2 plus 3, all square plus b into 1 minus 1, that is 0, into 2, 1 plus 3 plus c into 1 minus 1, that's 0. This is 8 plus 8 plus 9 equals a into 5 square plus 0 plus 0. So this is 16. 16 plus 9 is 25 equals 25a. A now equals 1. A is 1. So from this, if a is 1, we can also come back to this equation, 8s squared plus 8s plus 9 equals a into 4s squared plus 6s plus 9 plus bs minus b. Okay, that's b into 2s squared plus 3s minus 2s minus 3 plus c s minus c. So 8s squared plus 8s plus 9 equals 4a s squared plus 6as plus 9a plus 2bs squared plus bs minus 3b plus cs minus c. So that by comparison, 8s squared equals 4as squared plus 2bs squared. Okay, 8 equals 4a plus 2b, equation 1. Also, 8s equals 6as plus bs plus cs. 8 equals 6a plus b plus c, equation 2. Finally, 9 equals the constant 9a minus 3b minus c, equation 3. Recall that a is 1. We have gotten a to be 1. So we need to conclude to solve for b. Solving for b now. To solve for b, b and c. We have from that equation 8 equals 4a plus 2b. Recall a equals 1. So 2b equals 8 minus 4. 2b equals 4. b equals 2. So we need to solve for c. I want to clean here. To solve for c, we have that 8 equals 6a plus b plus c. 8 equals 6 times 1 plus 2 plus c. 8 equals 6 plus 2 plus c. C equals 0. Or we can use equation 3. 9 equals 9 times 1 minus 3 times 2 minus c. This is 6. C cannot be 0. Let's use equation 3. 9 equals 9a minus 3b minus c. 9 equals 9 times 1 minus 3 times 2 minus c. 9 equals 9 minus 6 minus c. 9 equals 3 minus c. C equals 9 minus 3. C equals minus 6. So, A equals 1, B equals 2, and C equals minus 6. Let's fix it in the solution. So, 8s squared plus 8s plus 9 all over s minus 1 into 2s plus 3 all square equals 1 over s minus 1 plus 2 all over 2s plus 3 minus 6 all over 2s plus 3 all square. So this is the solution of this partial fraction. That is solution to the partial fraction. That's 11a. 11b. The coordinates of the center and circumference of a circle are minus 2 and 5 and 6 pi units, respectively. The center and circumference of a circle, okay? Now, we are given circumference of a circle and the center of a circle. So, circumference of a circle is 2 pi r, which is equal to 6 pi. Pi here, it means the radius of circle is 3. And we know that r squared equals x minus a all squared plus y minus b all squared. General equation, x squared plus y squared plus 2gx plus 2fy plus c equals 0. Then center equals minus g comma minus h. Y radius r equals square root of g squared plus h squared minus c. Okay. Then, if you have the radius as 3, 3 equals center minus 2 square plus 5 square minus c. We have that 3 square equals minus 2 square is 4, 5 square is 25, c is this. This is 9 equals 29 minus c. So that 9 minus 29 equals minus c. Minus 20 equals minus c. Therefore, c equals 20. Now we have c. Recall original equation, x squared plus y squared plus 2g of x plus 2f of y plus c equals 0. We want to form the equation. That's s squared plus y squared plus 2. Your g here is minus minus is plus, meaning times 2x plus 2f. Our f is 5 in the question, but if you bring it here, that's minus 5 into y plus c, which is 20, equals 0. So now s squared plus y squared plus 4s minus 10y plus 20 equals 0. So the equation of this circle is what? S squared plus y squared plus 4s minus 10y plus 20 equals 0. That is the equation of the circle. This is question number 12. Okay, construct a cumulative frequency table for the distribution. We have max. Let me wipe this line so that it can contain. This is max. Number of candidates. Class boundary. Cumulative frequency. (11 to 20). 21 to 30, 539, 31 to 40, 14, 41 to 50, 40, 51 to 60, 57, 61 to 70, 25, 71 to 80, 11, 81 to 90, 8, 91 to 100, 1, lower class boundary equals number minus 0.5. Upper class boundary equals number plus 0.5. So, our lower class boundary, 11 minus 0.5 equals 10.5. 20 plus 0.5 equals 20.5. That's how you're going to do all. This is 10.5 to 20.5. Then 20.5 to 30.5. 30.5 to 40.5, 40.5 to 50.5, 50.5 to 60.5, 60.5 to 70.5, 70.5 to 80.5, 80.5 to 90.5, 90.5 to 100.5. So, we'll have cumulative frequency 5 plus 0 will give us 5. 5 plus 39 is 44 plus 14, 54, 58 plus this 138 plus this is 45, 195 plus this is 200, 220 plus this 231 plus this 239 plus this 240. Okay, before you can conclude, let's cross check. 5 plus 39, 5 plus 39 plus 14 plus 40 plus 57 plus 25 plus 11 plus 8 plus 1. Okay, that's 200. Meaning 5 plus 44. Plus 14, 58 plus 40. Okay, 98 plus 57, 155 plus 25, 180 plus 11, 191, 199, 200. So the frequency, cumulative frequency table for the distribution is what you have seen in above. The B part says draw a cumulative frequency curve for this distribution. So we need to draw a curve for this. To draw curve, you are plotting cumulative frequency against class boundary. So we don't need all this here. Let's come to this place and make a rough sketch of the graph. Okay, the highest is 200. You assign scale yourself. Waec will not give you scale. $20, $40, $60, $80, $100, $120, $140, $160, $180, $200, $220, $240. Why this way? You're starting from, this is 20.5, 30.5, 40.5, 50.5, 60.5, 70.5, 80.5, 90.5, 100.5. So when the cumulative frequency is 5, this was under 20.5. So division of our graph, as usual, what you assigned all over 2cm, this implies 20 all over 10 equals 2. So each whole represents 2. So if I have 1, 2, that is 4, and I'm interested to plot 5, it means the third one will be divided into 2. So it's under this point you plot. Circle it. The next is 44. This is 40. 44 is already easier. That's just 2 blocks. That's what you need. Then 58. This is 60. 58 should be somewhere here, okay? Then the next is 98 under 50 point. 98 close to 100, but not actually 100. 155, that's 60 point. 180, 70 point. 191, 80 point. That's 80.5 is under 191. 199. Then 200. So this is the graph. You are starting from here, okay? From the origin. You're going to know how to make use of your broom very well. This is just a rough sketch. Oh. This is a rough sketch. You have absolutely plotted the give. It's a rough sketch. So that is the solution for 12B. Let's see the 12C. Use the curve to estimate the number of candidates who scored marks between 24 and 58. And 58. So for marks, here represent your percentage. This is 10, 24 around 24. You trace back. Then 58. You trace it up. Though this is a rough graph, it cannot give us exactly what we need. So when you trace, you get your value. You subtract so you can know the exact number of students. Likewise, use the curve to estimate the lowest mark for distinction if 12% of candidates pass with distinction. Meaning if 12 pass, there are certain number that did not pass. That is 100 minus 12. How many did not pass? 90. That's 90. 100 minus 12. 88 did not pass with distinction. That's 88 over 100 times 200. That is 8. 8 times 2 equals 176. You come back to your graph. This is 170 somewhere here. 176 will be in between. So you trace. You trace it down. To calculate this, here is 70, and here is almost 8 squares. So 70.5 plus 8 equals 78.5%. So that is the percentage. Okay, that is that for question number 12. Question number 13 is probability, because I told you in section C is probability and statistics pure. A bag contains 16 identical balls, of which 4 are green. A boy picked a ball at random from the bag and replace it. If this is repeated 5 times, what is the probability that he did not pick a green ball? Okay, let me clean here first. That's question number 13. A bag contains 16 identical balls, 4 which are green. Total number of balls. Green. N is 5. So whenever you see 5 times a number is given, we are talking about binomial distribution, probably under binomial distribution. That is n combination r into p raised to the power n, q raised to the power n minus r. This is what they are talking about. This formula, where n combination r could be the PR, probability of zero, 1, 2, depending on the number. So here now P is success. So if the boy succeeded picking 4 green, meaning the success here is 4 over 16. That is 1 over 4, okay? Now Q here now will be what? 1 minus P. Q now equals 1 minus 1 over 4. Q equals 3 over 4. So the failure is 3 over 4. And n here is 5. Now the question is, find the probability that he did not pick a green ball. Probability that the ball did not pick green ball means 5 combination 0 into 1 over 4 raised to power 0 into 3 over 4 raised to power n is what? 5 minus 0. So probability that he did not pick a green ball equals or implies 5 combination 0 into 1 into 3 over 4 raised to power 5 to give us 5 combination 0 is 1 times 1. 5 combination 0 equals 1. 3 over 4, 0 0.75 raised to power 3. This will give us raised to power 3 raised to power 5, 0.75 raised to power 5, 0.23730. So this is the probability that he did not pick green ball. Also, find the probability that he picked a green ball at least 3 times. At least 3 times. To pick green ball at least 3 times. At least 3 means from 3 upwards. PR of at least 3 times implies 5 combination 3 into 1/4 raised to power 3 into 3/4 power 5 minus 3 plus 5 combination 4 into 1/4 into 4 into 3/4 5 minus 4 plus 5 combination 5. Okay, the total number of green ball is 4, 3, 4. So that's where you are to stop. Because total number of green is just 4. So 5 combination 3 will give us 5 combination 3 equals 10 times 1/4 0.25 raised to power 3 0.75 raised to power 2 plus 5 combination 4 5 into 0.25 power 4 into 0.75 power 1 power 0.25 raised to power 3 10 times 0.015625 times 0.23730 plus 5 multiplied by 0.25 power 5 power 4 0.00390,625 multiplied by 0.75. This will give us 0.15625 times 0.23730 plus 0.23730 times 0.75. Point 0.15625 times 0.23730 730 equals 0.037078125 plus 0.003900625 times 5 times 0.75. 0.014684 plus 0.037078125 equals 0.05172656. They give us 0.05173. So that is the probability of at least 3. So this is the end of question number 13 AII. Okay, still on question number 13B. The deviation from a mean of values from a set of data are -2, m minus 1, minus 1, 2, m squared plus 1, 2m minus 1, and minus 2. Find the possible values of m. Okay, this question says deviation. Sums of deviations of mean equals 0. So look at what we are going to have here. -2 plus m minus 1 plus m squared plus 1 plus minus 1 plus 2 plus 2m minus 1 plus minus 2 all equals 0. So -2 minus 1 is -3, plus 1 minus 2, minus 1 minus 3, plus 2 minus 1, minus 1 minus 2, minus 2 minus 4. Let's look at m. m plus 2m, 3m, then plus m squared. Everything equals 0. So looking at this, m squared plus 3m minus 4 equals 0. This is what? A quadratic equation. It has led to quadratic equation. Now we have to factorize. Factorizing this, we have that linking these two together to produce minus 4m squared. So bringing down m squared, what are the two numbers? When you multiply, it will give us 4m squared. When you add them together, we subtract, it will give us plus 3m. The two numbers are what? 4m and minus m. So here, m is common. Factoring m out, plus 4 minus m into, this is minus 1 into m plus 4 equals 0. So that m minus 1 into m plus 4 equals 0. Therefore, m equals 1 or minus 4. So this is solution for question number 13b. Going down to question number 14, we have this. A particle of mass 2 kg moves under the action of a constant force Fn with an initial velocity 3I plus 2j meter per second and velocity of 15I minus 4j meter per second after 4 seconds. Find the acceleration of the particle. It's a pure physics question in the form of vector. So there is vector in further mass, there is vector in physics. So the knowledge you have or you have gained from physics is going to help a lot in the aspect of formula. So what do? Recall that acceleration from first equation of motion, A equals what? V minus U all over T. Looking at what we have here, a particle with mass, this 2 kg, I will say mass equals 2 kilogram. Then initial velocity, which is U, equals 3I plus 2j meter per second. V equals 15I minus 4j meter per second. We also have T equals 4 seconds. Now, if you watch all the parameters we have here, I will need to solve acceleration. They are all here. That is, acceleration now equals V, which is 15I minus 4j minus bracket initial velocity 3I plus 2j divided by the what? Time taken. Therefore, acceleration equals 15I minus 3I minus 4j minus 2j all over 4. A equals 12I minus 6j all over 4. So that acceleration equals 3I minus 3j all over 2. What is the unit for acceleration? Meter per second square. So this is the acceleration of this particle. Now let's see what they have in mind next. The next question says, find the magnitude of the force. Recall that force F equals ma. Therefore, F equals mass. What is the mass? 2. Multiply by who? The acceleration, 3I minus 3j all over 2, to give us what? 6I minus 3j. The SI unit of force is what? Newton. But the question is magnitude of the force, that is absolute F. Magnitude of F equals square root of I squared plus j squared. To give us what? 6 squared plus minus 3 squared. To give us 36 plus 9. To give us sod 45. That is 3 square is 9. 6 square is 36. 36 plus 9 equals 45. Square root of 45 equals 3 sod 5. This is 3 sod 5. This is the magnitude of the force, or you can call it 6.70 Newton. This is what you have as the magnitude of the force, 6.708. Okay, let's see if we have another question under it. Okay, find the magnitude of velocity of the particles after 8 seconds. Okay, one said magnitude of the force, the other one magnitude of velocity of the particle after 8 seconds. Good. So look at what you have to do here. Let's make use of this way. The other side, recall. You know that V equals U plus AT from first equation of motion. Or if you feel like using this, no trouble. All you have to do, make V subject of the formula. So the magnitude of velocity here now, absolute V equals square root of whatever you have here, U plus AT, because you are dealing with magnitude. But then let us settle this in form of, as the formula has indicated, you have U to be initial velocity, that is 3I plus 2J plus A, which is acceleration. Then what is our acceleration? From the solution in above, our acceleration shows that it is 3I minus 3J all over 2, then multiply by the time taken after 8 seconds is the time, that is multiplied by 8. So V equals 3I plus 2J plus 24I minus 12J. That is, if I expand this place, 3I minus 3J all over 2, multiply both by 8, this is 24. This will take care of this. This is 4. 4 times 3 is 12. That is the minus 12J. Okay, that is, by the way, our business here is to get the magnitude of this velocity. 3I plus 24J is 27I. This minus 10J. So V, the magnitude of V equals what? 27 squared plus minus 10 squared, to give us square root of 27 squared, 729 plus 100. That is 829. 829. Square root of 829. 829 equals magnitude of velocity equals 28.79 meter per second. But the instruction is to 3 decimal places. So writing down the values we have here, 23601. 1, 2, 3. So our solution is 28.792, because 3 cannot approximate, so meter per seconds. The magnitude of the velocity is what? 28.792 meter per seconds. Next question is question number 15A. A seesaw pivoted at the middle is kept in a balance by weights of Richard, John, and Philip, such that only Richard, whose mass is 60 kilograms, sits on one side. Okay? If they sit at distance 2 meter, 3 meter, and 4 meter respectively, from the pivot, and Philip is 15 kg. Find the mass of John. Now this question, they are interested in the mass of John. Okay, remember, this is principle of moment. Principle of moment. So we are done with vector in disguise. Though force and velocity was the question, but if you see the I and J, you should know that it is a symbol for vector. Guys, we have a lot to do with meter rule. If Richard is sitting on one side, okay, let's say Richard is sitting this way. The mass of Richard is 60 kg. Let's say from this pivot, his distance is 2 meters. Other people, 3 and 4. Let's say 3 meters. The last one here, 1 plus 3, which is 4 meters. Let's say okay. 2 more people are remaining, Richard, John, and Philip. We have to look for the mass of John. The one for Philip is already known. So be what? 15 kg. What is the rule for principle of moment? Sum of clockwise moment equals sum of anti-clockwise moment. Looking at this diagram, we have that M1 times, that is the mass of John. Find the mass of John, multiply by the distance covered by John, plus, first of all, write down the formula. That's sum of clockwise moment equals sum of anti-clockwise moment. Okay, M1 times 3 plus 15 times 4 equals 2 times 60. That is 3M. Let's just say, call it M, mass of John. 3M plus 60 equals 120. 120. Subtracting 60 from both sides, we have 3M equals 60. Divide through, we have that mass of John equals 20 kg, 20 kilogram. So the mass of John is 20 kilogram. So that is the solution for question number 15A. 15A, 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 15bi, a body of mass 12 kg rests on a rough plane inclined at an angle of 30 degrees to the horizontal. The coefficient of friction between the body and the plane is 2/3. A force of magnitude P Newton acts on the body along the inclined plane. Find the value of P if the body is at the point of moving down the plane. This topic is friction in physics. Okay, so since this is friction, one may ask, is it physics we are solving or further mass? The answer is further mass. Physics is like a song to further mass. Okay. Now we have this. You all know this diagram. This side is what? mg cos theta. And this side is neon this. That is which is mg sin theta. So if this makes an angle of 30 degrees, the mass of this, that's 12 kg. This is 12 kg. This body. So P is somewhere here. Our interest is to find the value of P. Okay. Now, we need to know the summation f of 0. The vertical is first. F of y equals 0. The vertical n minus mg cos theta equals 0. So that we want to get that's the n, the symbol n minus this. What's the mass? 12 times 10 cos 30 degrees. If you transfer this, n becomes 0 plus mg cos theta. 0 plus any number maintains that same number. So no need of wasting our energy. This is 120. Cos 30 is sort 3 all over 2. 2 here, 2 here. And now equals 60 sort 3 Newton. You have this. Now, at the point of moving down, that's the horizontal side, summation f of s equals 0. So to move down now, we are dealing with this part. We give us neum n minus p. The value of p we are to look for minus mg sin theta equals 0. Horizontal and vertical components. Vector, we say, resolving into horizontal and vertical components. Of course, you know, Fy, you are talking about the vertical, Yx is the horizontal components. So now, recall that neum equals what? Coefficient of friction, Cf. So what's the coefficient of friction? You were told is 2 over 3. Multiply by this, that's 60 sod 3 minus P minus 12 times 10 sine 30 degrees equals 0. Okay? Or if you have this, this is going to give us 3 here is 20 bracket 20 sod 3 120 minus p minus 120 multiplied by 1 over 2 equals 0. So 40 sod 3 minus p minus 60 equals 0. So we have now 40 sod 3 minus 60 equals 0 plus p. Like I said earlier, 0 added to any number or variable remains that same value. So 0 has nothing to produce. So p is this. Therefore, p equals, if I factor out, this is 20 bracket 2 sod 3 minus 3. So p now is this. But if you wish to interpret all your values, no issue. But if you decide to leave your solution in sodic form, no trouble. Let's see if there is another question. Okay, find the value. Okay, value of if the body is at the point of moving the plane. Okay, the first one, moving down the plane, which you had the value of, that's 60 sod 3 Newton. Then now the real value of p when this body is about to move down the plane, up the plane, is what? 20, or just a 40 sod 3 minus 60 equals what? P. So that is the final answer for question number 15B II. Ladies and gentlemen, at this juncture, I want to tell all of you to remain blessed as you wait for 2024 further mathematics, which is still loading.